Greetings, students. Today we'll go through part 2 of this, and we're going to look at the trigonometric identities, odd and even identities. And first of all, really to understand that, you need probably a little review on what even and odd functions mean in the first place. So I'm going to start that way. So basically, a function is even if f of negative x equals f of x for all values of the function x. I'll explain what that is in just a minute. And a function's odd if f of negative x equals negative f of x for all x values of the function. So if you look at these two diagrams right here, here's an example of an even function. And I always try to get students to kind of just think this in their head. When you have an opposite y, it means you have the same y. So notice on here, if you look at this point on the graph, that has an x value, that's an opposite x value. Well, it has the same function value, so it has the same height on the graph. You can think of it that way. And if it's an even function, it's symmetric about the y-axis. Right? An odd function, you want to think of it this way. If x is opposite, then so is y. So notice on here, here's an x value, there's an opposite x value. Notice that you have opposite y values. And what that makes that symmetric about the origin. Okay. So again, as we kind of go through this, just remember that even functions are symmetric about the y-axis. And a function's odd, that's symmetric about the origin. And we'll go into that a little bit more in depth here in a minute. If the point 3, 4 is on a graph, and it's an even function, well, what that means is opposite x gives same y. All right, so that's what an even function is. Every time you have an opposite x, you have the same y. That's real simple. That's the idea. And in general, if you have a point xy is on the graph and the function even, then it just means when x is opposite, y is the same. All right, so that's what's meant by an even function. A specific example on this, if you have the point negative 2, 4, and that's on the graph of an odd function, then here's what it means. If you take the opposite x, which in this case would be 2, you would also have the opposite y, which would be negative 4. And in general, if you have a point xy on a graph of an odd function, just same thing. If x is opposite, then also is y. That's all it is, okay? All right, so going to this next page, let's just kind of look at some graphs, and this is just kind of review to prepare us for the trig part. Okay, so we want to see if this graph is even, odd, or neither. Well, one way to look at this is look at the symmetry. So, for example, this point right here is the point 1, 1, and notice this point over here is the point negative 1, negative 1. Now, what you would find is every point on this graph works this way. I'm just going to approximate that is maybe that's the point 3 and maybe it's 1/3. I'm just estimating. Well, notice this point here is the point negative 3, negative 1/3. So that's what an odd function does. And again, that's symmetric about the origin. So that's what you want to know how to do. Another way to look at origin symmetry is imagine you took this graph and folded it. You cut it out with scissors on a piece of paper. You folded it over y. Then you folded it over x. And those two graphs would come together. Or you can think of it as kind of symmetric about that diagonal. Those two graphs come together. Okay, next example, again, let's look at this. So let's just kind of estimate a couple of points. It's kind of hard to tell on here, but I'm just going to predict maybe a couple. So it looks like that point is the point 1, negative 1. So notice you have a point negative 1, negative 1. So again, what that means is when you have an opposite x, then it means you have the same y. And every point on this graph would be that way. Like this point here and this point here are going to have opposite x values, but they're going to have the same y value. So that's kind of the idea. So that is what an even function is. And then this one is symmetric about the y-axis, which just means if you folded this graph over the y-axis, they would match perfectly. Okay? So again, I kind of try to get students to think of even functions this way. Opposite x, same y. If it's an odd function, I try to get students to remember it this way: opposite y, opposite x, opposite y. Just get that in your mind. Okay, the next one, it doesn't have either of the types of symmetry. So notice on this one, that looks like you have a 0.14. Notice that over here, you don't have a point -1, 4. So it wouldn't be even. Also, you don't have a point -1, -4 in the graph, so it couldn't be odd, so it has to be neither. So that one does not have either of the symmetries we would expect for an even or odd function to have. Okay. Now, to kind of wrap up the review here, what I want to look at is just some graphs. And this one is a quadratic function, so we're going to go through and make a table of values on this then. So I'm just going to pick some values: -2, -1, 0, 1, 2. That way we can kind of address the symmetry of this. And what we're going to do is we're just going to evaluate the function x squared plus 1 at those points. When I do this, I always tell students when you're evaluating a function, just create a framework so that you don't do the arithmetic wrong. You're just taking a number squared plus 1. That's why I'm using a parenthesis. So this would be 4 plus 1, so that would be 5. You're welcome to do all this in your head. This would be 1 plus 1, so that's 2. This would be 0 plus 1, so that's 1. This is 1 plus 1, so that's 2. And did I just, yeah, okay, then I've got 2 squared plus 1 equals 5. All right, so I'm good. I just want to make sure I'm doing that right. Okay, now I'm going to go over and just graph these points, so go ahead and do that. Your left 2 up 5, your left 1 up 2, 0, 1, 1, 2, and over 2 up 5 like that. So that's what the graph of that function looks like. So what we're going to do is look at if it's even, odd, or neither. So what do you think? Okay, yes, it's definitely even. And the reason's real simple. You can see this in the table of values. You can see that opposite x's gave the same y. Okay, you can see it in this point also. All right, you have -2, 5, 2, 5. Again, opposite x's gave same y. All right, and that's good enough. The technical reason is f of -x is equal to f of x. Okay, in words, again, that just means, like I've been saying, opposite x always is going to have the same y every point on the function. Now this one right here, you know, you can't do the opposite of 0, but technically if you did -0, you still get 1, okay, because -0 is 0, so that still counts. Okay, so that's a good example of an even function, and again, it's symmetric about y. Okay, that's another reason, if you want to say that, that's symmetric about the y-axis. Okay, moving on to the next one here, x to the third. Okay, we're going to do this the same way. We're going to pick points, and just to demonstrate this, the same x values are good things to use. And we're doing a cubic function, so what we're doing is we're just cubing each x value that we chose, and then we're going to plot the points. Okay, so if you have -2 to the third, remember that means that you're multiplying out 3 negatives, so that's -8. If you do the same with -1, -1 times itself 3 times gives -1. 0 to the third is 0. 1 to the third is 3. That's a mistake I see students do all the time. 1 to the third is 1. And then 2 to the third, not 6, it's 2 times 2 times 2 is 8. Okay, those are little mistakes that are, if you're not paying attention, you can make. Okay, so what I'm going to do is I'm going to graph these points. So go ahead and do that. So just go left 2, down 8, left 1, down 1, 0, 0, 1, 1, and then 2, 8 like that. And then that gives the graph of what a basic cubic function looks like that. Okay, well, what kind of function is it, do you think? Odd, even, neither? What do you think? Very good, it's odd. Okay, so this is an odd function. The reason is, there's several ways to think of this, is, okay, you have every time you have an opposite x, you have a opposite y. And you can clearly see that in the chart. -2, 2. -8, 8. -1, 1. -1, 1. Every time you have an opposite x, you have a opposite y. Okay? More technically, you would say f of negative x is the opposite of the original function value. That's the technical terminology. And also, it's symmetric about the origin. Okay. All right, questions? Okay, all right, let's do one more, and then we'll enter the realm of trigonometry. I feel like students really need a good review on this to understand the trig identities, though, so I want to take the time to do that. Let's see, with this one, I'm going to give you some points to do on this. I'm going to do this one a little bit different. I'm going to do probably 0, 1, 2, 3, 4. Okay, it doesn't really matter, but I'm just like, there's a reason why I'm choosing those numbers, and I think you'll see in a minute why. So what we're going to do is just plug in, so you'd have 0 minus 2 to the second. We'll work that out. 1 minus 2 to the second. 2 minus 2 to the second. 3 minus 2 to the second. And then finally 4 minus 2 to the second. Okay, you just follow order of operations. Again, you can do all this in your head. That's negative 2 to the second, so that's positive 4. The next one is negative 1 to the second, so that's positive 1. Then 0 to the second is 0. Then 1 to the second is 1. And 2 to the second is going to be 4 like that. I just sort of picked points so I could see, you know, the symmetry about the vertex on this quadratic function. So plot the points. So you'd have 0, 4, 1, 1, 2, zip, 3, 1, and 4, 4. Okay, so what you're doing is you're looking at, does it have any symmetry? Okay, it's definitely not symmetric about y. It's not symmetric about the origin. So it doesn't have any of the features we would expect on here for it to be odd or even. So it's really neither. So basically, the technical way to explain this is f of negative x is not equal to f of x. So in other words, opposite x's don't give you the same y. Okay, and the other one would be opposite x's do not give opposite y's. So it's neither of those. You could also say it's not symmetric about the origin or the y-axis. Okay, so that one doesn't have the symmetry. And if you went to one more point, like if I would have chose negative 1 here, and if I would have done negative 1 minus 2 to the second, that would give 9. So this right here kind of is enough to show that it's neither even or odd. Okay, that you didn't end up having either the same y or you didn't have the same x when x was, or same y when x was opposite. So that point right there is kind of what we would call a counterexample to prove that it's not odd or even. Okay, so that'll kind of wrap up the review part of this. Then we'll get into the trig part, and I think you'll understand the trig part a lot better on the next page once you understand what we reviewed. Okay, so going to the next page here. So what we're going to look at on the trig identities is we're going to look at which trig functions are even and which are odd. A trig identity, and we'll be talking extensively in this class about trigonometric identities. All it is it's an equation that's always true for every angle theta or whatever that angle is. Okay, a lot of times, like in these identities, we're just using x as the angle, whatever that variable is. So it turns out, and it's real helpful to see this by crunching out points, and when we get to graphing, it'll be even better. You'll understand it, I think, even better. But what you want to know is there's two even trig functions. They are the cosine and the secant. And of course, cosine and secant are reciprocal relations of each other. So the definition, again, is opposite x gives same y. That's why the trig identity is saying the cosine of an opposite angle is still just the same function value as if you just did the cosine of x. Same thing here. That's how the even identity is written like that. It turns out that we have 4 even functions, or odd function. I keep saying this backwards. They are the sine, cosecant, the tangent, and cotangent. So 4 odd functions, 2 even functions. All right, and then we'll kind of look specifically at why that is. And again, it follows the definition. When you have an opposite x, you also have an opposite y. So here's your opposite x, there's your opposite y in that sign there. Okay, so it's just kind of like this, opposite x, opposite y. That's what that means. And that negative sign x is really given a y value, but it's the opposite of the original. So those identities you have to memorize. But what I always try to get students to do is understand the identities. And if you understand how even and odd functions work, then you build the identities. That's the way I did it. I don't blindly memorize any of this stuff. I understand it. And if you do the same, then you will remember it fine. You'll just be able to create it on the spot when you need it. What you can't forget is what an even and odd function are. All right, so just write this down. It's in the diagram. So the even functions are the cosine and the secant. You can abbreviate that if you want to. The odd functions are the sine, the cosecant, those are reciprocals, and then the tangent and the cotangent. So it's helpful that you remember that, and I think once you learn the graphs of all these trig functions, you'll remember it better. Okay, but I'll show you how you can figure this out anyway. All right, so I think I've said this enough. I have a tendency when I teach to kind of say things over and over and over again to emphasize stuff. But the odd function means opposite x, same y. Even function, opposite x. Whoa, I wrote that down wrong, guys. This is a major mistake. I'm glad that I put that on there. Sometimes I don't check my notes when I type these out. So it goes this way. Even function, opposite x, same y. Odd function, opposite x, opposite y. Okay, gosh, as much as I emphasize that, and I still typed it wrong. Okay, all right. So let's kind of look at why this is a little bit. I'm going to zoom on this diagram a little bit so I can see it a little bit better. So let's look at why. All right, so one way to look at the cosine and the negative cosine is kind of like this. So if you look at this diagram right here, we know in the unit circle, the cosine is an x value, and we know the sine is a y value. So we're just going to focus kind of on the cosine and sine here. Well, in this diagram, you would have theta. That would be I'm just using a quadrant 1 angle as an example. But if you did negative theta, that would be a negative angle, so it's clockwise, so that would put you down in quadrant 4. So what would happen on this then is you would end up having this then. And I'll just give you an example on the unit circle. So basically, you would have your x value would be a cosine. So that would be the cosine theta, all right? Well, if you look at this down here, if you look at this point down here, the x value is still the cosine theta. So if the angle became opposite, then the x value stayed the same. Okay, that's why it's an even function, is the opposite angle, still you get the same value, you get the same x value. Okay, that's the key thing, is it's the same x value like that. Okay, so that's why you would do that. Is what my question is here, is the value of the cosine and cosine negative theta the same or different? They're the same, therefore you have an even function. Okay, that's what that diagram is showing. And then if you look at the sine, remember the sine on a unit circle is the y value. All right, well, you have a positive y there, but here you would have a negative y value because you're down below. So that would actually be a negative number. So what's going to happen on this is positive y, negative y. So what this is saying is if you compare sine theta with sine negative theta, they're different. So what they are is they're opposites. Therefore, that would be an odd function. So that diagram shows that is if you do an opposite theta, well, cosine stays the same because it's an x value. But the sine changes signs because it's a y value. Y is different in quadrant 1 and quadrant 4. So I hope that makes sense to you. All right. So I'm going to look at one more thing before I go to the next page, and I just want to kind of show you this. I'm going to pause for just a minute here, and I'll come right back to it. Okay, like magic, a unit circle appears. So I think it's important you see on the unit circle, it'll tell whether the functions are even or odd. So again, just check this out. This is what I was showing you basically is the cosine is the x value. So notice on this diagram right here, well, if you have the cosine of 30, you have root 3 over 2, but the cosine of negative 30, what's the cosine of negative 30? It's the same. See, and that's the point is because of that symmetry, that shows that it's an even function. And notice that's the same on 60. See, they're the same. Okay, even if you go over here, they're the same. Okay, like if you do cosine of 150, you could do like a reference angle. So you could think of that reference angle as 30 and that reference angle of negative 30. Well, they still have the same x value. So the cosine remains the same if the angle becomes opposite. And if you look at it, it doesn't matter what the angle is. It just always ends up being that same way. Okay, all right. So, and then the sine, I'll erase that and kind of show you the sine like this. So if you're looking at 30 degrees, look at this. Well, the sine is opposite. Okay, so if you were doing the sine of 30 degrees, that's equal to a half, but the sine of negative 30 is going to be negative 1/2. That's why it's an odd function. So the unit circle, I always tell students, is kind of like the god of trigonometry. It kind of tells you everything. All of trigonometry is sort of embedded in that magical diagram right there. So hopefully that helps you to see that visually as to why the functions are odd or even. Okay, very good. Okay, so I'm going to go to the next page, and what I want to do here is just look at the other ones real quick, and I'm going to look at the other diagrams on a unit circle. So I'm going to paste this unit circle and kind of show you this way. Well, one way to think of the other trig functions is the cosecant is the reciprocal of the sine, so it would kind of be the same idea. So like on this unit circle, let's just use 30 as an example, and then negative 30. So if you did the cosecant of 30, you actually just get the reciprocal of y, so that's 2 over 1. And then if you did the cosecant of negative 30, you would again get the reciprocal of that, so it's negative 2. So again, opposite x, opposite y tells you that that function's odd. Okay, so that's different. So you'd basically end up with cosecant of negative theta is equal to negative cosecant of theta. Okay, like that. So it's an odd function. Right? And then the secant works like this. So if we did the secant of 30 degrees, okay, the secant is the reciprocal of the cosine. So that would be 2 over root 3. But if you did the secant of negative 30 degrees, okay, that would be the reciprocal of the x value. So it's still 2 over root 3. So it's an even function as a result. So that would end up being the same, so it would be an even function. Therefore, we could say the secant of negative theta is just equal to what the secant is. Okay, so it's just that symmetry of how x and y work when the angle becomes opposite. That's really what it's all about. Okay, the tangent works like this. Tangent might be a little bit harder for students to see sometimes. But if you look at this same unit circle diagram, what I can show you on this is if you were to look at, and let's just pick some point, let's just pick like 60 degrees just for something different. So you would have 60 degrees here and then negative 60 degrees here. Well, what we know is the tangent of 60 degrees is y over x. So it would be root 3 over 2 all over 1/2. So that's equal to root 3. Okay. And then if you did the tangent of negative 60, well, it'd be the same thing. You would go down here, it would be y over x, so now it would be negative root 3 over 2 over 1/2. Well, now you would get negative root 3 after the 2's cross out. So again, what that demonstrates is when x is opposite, when the angle's opposite, so is the function. So the tangent would be an odd function as a result. So that would be different. That's an odd function. Therefore, we would say the tangent of negative theta is the opposite of the tangent. Okay, like that. And then the cotangent's the same way. Since the cotangent's the reciprocal of the tangent, it works the same way. All right, so you would end up getting an odd function with cotangent, and then you could conclude that cotangent of negative theta is equal to negative cotangent theta. Okay, so that's it. If you're not real clear on that, just pause and think about it a little bit. You can see how that symmetry works on an odd function. Okay. Okay, so one more thing, and then we'll kind of get to the types of problems that you want to learn how to do. I'm going to do this real quick. I probably have made it clear enough with the unit circle. That's good enough. But remember, the unit circle comes from special triangles. So I'm going to have you just draw a diagram like this. And we're going to make a 30, 60 right triangle. So it would kind of go like this. So the sides go 1 there, 2, and then this side right here becomes square root of 3. Okay. Well, if you did a triangle down here, if you did the same triangle here, so like if you went down like this, but you went straight down like this, well, that's still 30, 60 right triangle. And if you wanted to use these y values, that y value there would be -1. The hypotenuse is still 2. So what happens on this, it's the y values that are opposites. Okay, and that's what makes the sine an odd function. But the x values are the same. So x is just square root of 3 in both situations. So that's what makes the cosine an even function. And then the reciprocals go this way. So if the sine's odd, so is the cosecant. If the cosine's even, so is the secant. Okay, that's how that works out. Same thing, you don't need to worry too much about that. I think the unit circle is the best way to look at whether a trig function's odd or even. Okay, all right, so now on the next page, we're going to do some things here. We don't need a calculator for this or anything. It's just we need to understand the identities. Okay, so as I'm going through these problems, and they're real simple, if you've caught on to what we're doing here, what you got to remember basically is this. So the even functions are the cosine and the secant. The odd functions are the rest of them. The sine, the cosecant, the tangent, and the cotangent. That's what we've concluded. Okay, even functions work like this. F of negative x equals f of x. And then odd functions work like this. F of negative x is equal to negative f of x. You don't have to write that down unless you feel that's important to you. So again, one more time, opposite x, same y. That's how even functions work. Odd functions, opposite x, opposite y. I think that'll stick in your head. Okay, so that's all you got to think about in this. All right, a sine is an odd function. So opposite angle, opposite y. That's how that goes. So you just got to know which is which. Okay. A cosine is an even function. Even function, opposite angle, same y value. Okay, so that's what that means. All right. Okay, same thing here. Tangent is an odd function. So opposite angle, opposite y. So that changes to 2.5. Okay, secant is an even function. The way an even function works is opposite angle, same y. So that stays the same. Okay. And let's see, the next two. Cosecant is an odd function. The way odd functions work is opposite angle, opposite y. All right, so you just got to know which is even and which is odd. Cotangent is an odd function. So again, opposite angle, opposite y value, like that. That's all there is to that, okay? So I'm going to let you go just work out real quickly the next page, or not next page, next set of problems to make sure that you understand how these identities work, and then we'll move on from here. I'm also going to show you something on the calculator. So I'm going to pause this. It should just take you a very brief amount of time to finish this up. Okay, so here's what you should have came up with. Cosine's an even function. Therefore, opposite angle gives same y. The number 4 is also even. A secant's even. So again, notice opposite angle, same y. The other two are odd. Tangent and sine are odd. So again, opposite angle, opposite y. Sine, same way. Opposite angle, opposite y. So that's it. Okay, I'm going to pull up my calculator for a second here and show you this also real quick. I'm going to put my calculator in degree mode. And I'm just going to demonstrate this real quick with a couple examples. Okay, let's say you have the sine of 55 degrees. Okay, what you'll get is you'll get a bunch of decimals. This is not a special angle on the unit circle, so you get that. And then if I do the sine of negative 55, I want you to tell me what you think is going to happen on the calculator. There you go. You get the opposite y. Okay, now let's do a cosine. Cosine, pick an angle, 69 degrees. In fact, let's not even do an acute angle. Let's do like this. Let's do cosine of 125 degrees. Okay, I got an answer. So tell me what you think is going to happen when I do cosine of negative 125, since it's an even function. You get the same thing. Okay, your calculator is another way to tell you whether something's an even or odd function. The calculator is programmed to know that. Based on the way it figures these out, it's always going to do that. And there's one more. Tangent of, let's see, 260 degrees. Okay, you get some value. Okay, well, if I do the tangent of negative 260, since it's an odd function, what's going to happen? I get that. Okay, so see, the calculator clearly demonstrates that, and it isn't going to go wrong. All right? Okay, so next kind of thing we're going to look at here is determining if a function, given function's odd, even, or neither. So we're going to look at algebraically kind of how you would take any function, any trig function, and any trig expression and try to determine if it's odd or even or neither. Okay, so here's what you do. First thing you do is you replace all the x values with negative x because you want to see what happens when you make the angle opposite. If it's the same as the original, okay, then it's an even function. That's what we've learned. If it's the opposite of the original function, then it's odd. If it's neither the same or opposite, then it's neither odd or even. So that's what we've learned. Okay, and just a couple of quick illustrations. So if you have a point 10, negative 3 on the graph, and f of x is even, then tell me what the y value would be. Opposite x, opposite y, good. Okay, if you have a point 3, 4, and you're odd, if x is opposite, tell me what y is. Okay, y is odd. I just made a mistake. A lot of you probably caught me on that too. Okay, so if it's an even function, if x is opposite, then you get the same y. Sometimes I can't talk and think at the same time. Now I did it again. Okay, if you have an even function, you have the same y. All right. If you have an odd function, you have an opposite y. Now I think I got it. I'm confusing myself. Okay, all right. Very good. Okay, so the next thing right here, this is usually what's a little harder for students on this section, is this part right here. And this will be kind of to wrap up this part of the lecture, is I'm giving you just some functions that I've made up that have trigonometric functions in it. We're going to determine if it's even, odd, or neither. So step one is you always want to do this way, and you want to write your steps exactly the way I'm writing it here, because you get higher in math and then you start getting more technical with the way you write things. So step one is just everywhere you see x, replace it with negative x. Now, cosine squared, I don't know if this has popped up in this class yet. That just means cosine times cosine. That just means you're multiplying the cosine by itself. So a good way to write this is like this. I'm going to say cosine of negative x, and that whole thing squared, and then that's a minus sign, so I'll say minus sine of negative x, and then the whole thing gets squared. Okay, So what we have here then is this. Next step is you just need to know which function's even and which function's odd. Okay, and the idea is the cosine is an even function. So what that means is cosine of negative x would just stay the same. Okay, if you look back at your identities, that's what the identity said, is the cosine of negative x is equal to the cosine of x. Okay, that's that identity. All right. The sine is an odd function, so this would go like this. I need to write that like that. So since the sine is odd, then you would get negative sine of x. Okay, and again, that identity says this. The identity you learned says sine of negative x equals negative sine of x. So I'm just applying that identity, but if you know that it's an even and odd function, you can create that identity. Okay, so what you end up getting is you end up getting this. Okay, when you square this cosine, that just becomes cosine squared x, so I write it that way. You have your minus sign, so bring it down. And when you square a negative number, that just becomes sine squared x. Okay, like that. All right, so that's how it goes. You're squaring a negative number. You're just doing negative sine x times negative sine x, so that gives you a positive number. Now what you do is you compare the original statement with your result. So what do you notice? Exactly, they're the same. So since they're the same, that means that you just end up with that original function f of x. So what you conclude is when you had an opposite x, you got the same y. So now you can say therefore, the three dots stand for therefore, it's an even function. Now that's the way, that's kind of a really a small proof that that is an even function. And that's the way you want to write that out. Always start with f of negative x, replace all the x's with negatives, work out the algebra, and then see if you end up with f of x or negative f of x or something totally different. That's the idea, okay? All right, so I'm going to do one thing here real quick. Okay, so like magic, this diagram pops up. So I'm just going to kind of put this to the side to refer to it. I prefer that you never have to look at this. And I'm trying to teach it in such a way that you know which functions are even odd, and you understand even and odd so well that you can create the identity as you need it. Okay, let's go to the next one. And again, you're going to start this proof the same way. So we're always going to start this way. F of negative x equals. Don't start these problems any other way. Then everywhere you see an x, replace those x's with negative x's. So you would have sine negative x, cosine negative x like that. Okay, now again, like I said, I prefer that you don't have to look at this. Okay, what I prefer is that you know that the sine is an odd function. So since it's an odd function, that will become negative sine x. The cosine's an even function, so since it's an even function, that will just become cosine of x. So notice what I did on this is the sine of negative x is negative sine x. That's what I did. I used that identity. The cosine of negative x is cosine x, so I'm using that identity. So now, what do we have? Well, I have a negative number here. So if I multiplied this out, I'd have a negative times 2 is negative 2. Don't really need the brackets anymore. I get sine x, cosine x. All right? Now what you always do is you always compare the original to what you ended up with. So what do you notice about 2 sine x cosine x and negative 2 sine x cosine x? They're opposites. Very good. Since they're opposites, you write negative f of x. Okay, and the conclusion we come up with then is f of negative x is negative f of x. That's therefore an odd function. So we say therefore we have just proved that's an odd function. So that's the idea. Okay, so it's very methodical what you do. If it turned out the same, it was even. If it turned out to be the opposite, then it's odd. That's all there is to it. Okay? All right, this next one, I've probably given you another example. This is a cosecant. So again, start this way. Don't start it any other way. Say g of theta, g of negative theta is equal to 1 plus cosecant of negative theta. Okay, well, you got the identity over at the right here. Try not to look at it, though. Cosecant is an odd function. Since it's an odd function, this becomes negative cosecant of theta. So that ends up giving you 1 minus cosecant of theta. Now you're ready to compare the original function I gave you, which is this, to the final thing that we got. So you have to ask yourself two questions. Are they the same? Well, they're not the same because one of the signs is different. Are they opposites? Now, be careful. A lot of students would think they're opposites, but they're not. Okay, so let me show you this. If you want to do the opposite of 1 plus cosecant theta, you would have to multiply the whole entire thing by -1, and you would get this. They are not opposites. They're clearly not the same. Therefore, this one would be neither odd nor even. Be real careful about that, okay? The way you make something opposite is you multiply the entire thing by -1, okay? If it's a fraction, like for instance, if you had something like sine theta over cosine theta, the way you make that opposite is when you multiply a fraction by -1, then just one, really one part becomes negative. Okay, so that's a fraction. You're really just one, either the numerator or denominator gets multiplied by -1, but not both of them. That's because you're multiplying by -1 over 1, in a sense, okay? Okay, so let's see. We'll wrap this lecture up, this part of the lecture up, let you do the next examples. So I'm going to go ahead and have you pause. I'm going to move my diagram down here. Try not to look at this when you're doing these problems. But if you have to, you can. But try to get that in mind and build those ideas as you go. All right? So good luck. Check when you're ready. Okay, so it's time to check and see how you did here. So if you're getting all these right and understand it, then you are done with this part of the video. All right, so otherwise I'll explain it real quick if you need a quick explanation. Number one is it's an even function, so you get the same y value. Okay. Number two is an odd function, therefore you get the opposite y value. -4 becomes 4. Okay. The proofs go like this. Number three is an even function. So first thing I do is I write f of -t equals secant -t squared minus 1. And be sure you write this down right. If you don't have your proof real clear like I have it here, you need to get that adjusted. Because a lot of times students just kind of write stuff on their paper, and I can tell they don't really understand what's going on. So you want to write it this way. So the key thing is a secant is a even function. So notice over here, if it's an even function, that just becomes secant. Okay, so you got that. And then when you square the secant, you just get secant squared t. The -1 keeps bringing down. So if you notice, if you compare what I gave you to what you found, they are the same. Therefore, it's even. Okay. And then the next one, again, you start this way. F of -x, replace the first x with -x and the second x with -x. Okay, well, cosine is an even function. So again, the key was to replace cosine -x with cosine x. And by doing that, you would end up having in the next step just -x cosine x. And if you compare the original with the final, they are opposites. So since they're opposite, therefore it's an odd function. Now, if you didn't write this conclusion, write it. You want to always write that. Okay, f of -x became negative f of x. Over here, f of -t became f of t. And that's the idea. Okay, this one turned out to be neither. The key thing is you start off the proof the same way always. We change theta to negative theta. But the key thing is a tangent's an odd function. So if you look at the diagram, you have tangent -x equals -tan x. So you have 2 plus -tan theta. That's how that changes. So that just gives 2 minus tan theta. And then if you compare those, they're clearly not the same, and they're not opposite. Again, in order for this to be opposite, the opposite of 2 tan theta is negative 2 minus tan theta. So it's not opposite because the 2 is not opposite. Okay, and that's it. So hopefully that will take care of everything for even and odd functions. It's a pretty technical part of the section, but it's not too hard. All right, hope that helps to know your math good. Thanks for listening.